Hey friends, did you know Azure IoT Edge enables you to deploy cloud intelligence locally on IoT Edge devices? By moving certain workloads to the edge of your network, your devices can spend less time communicating with the cloud, they can react more quickly to local changes, and they can operate reliably even in extended offline periods. Paul DiCarlo is here to show me how this works by using IoT Edge with Cognitive Services containers to enhance my favorite retro video games today on Azure Friday. Hey friends, I'm Scott Hanselman and it's Azure Friday. I'm here with Paul DiCarlo, man after my own heart. I like your shirt. I like all the stuff on the back of your office there. I'm always peering into other people's offices and I say, here's a person that I could hang out with. We may or may not be the same person, Paul.
I've thought that. I've actually heard we actually cross interests in quite a few ways. Number one, I've heard you might have an affinity towards Goodwill and thrift shopping. And number two, retro video game passion.
I may or may not have a half dozen small, tiny arcades and or 3D printed Game Boys with Raspberry Pis inside within reach.
I think we are the same. Like, if I went downstairs, I'd show you the same. But again, who keeps an FM Towns Marty and a Commodore in their office?
Yeah.
And is that
who has a Space Orb with a USB-C CircuitPython Adafruit add-on by Vic Putz plugged in, so I've got a serial port to USB connector for a 25-year-old obsolete controller that only plays on one game. But
you know, we need to have an episode about that later on.
We do. But today, with the power of the cloud.
So what we'll be talking about today is pretty interesting. It's a tool, if you want to think about it, or even a demo that was sort of developed out of this passion that I have for really just exploring video games from time, place, geography, and that sort of thing. And funny how this all started. I'll go ahead and share my screen here and show off like a quick article I think that we have posted that really goes into this. Here you should see an article on Hackster.io that sort of walks through what we'll be talking about today, this retro video game translation tablet. This was a project that was sort of born out of a trip that I had taken, work-related, that landed me in Akihabara, which is a prefecture in Tokyo, Japan. And this is a place where you can really buy electronics from all over different eras, 80s and 90s, oftentimes in untouched condition. And this includes, of course, one of the things that I enjoy quite a bit, video games. And as you see here in this spread, a lot of the games that you would encounter there are, of course, going to be presented in the Japanese language. And unfortunately for myself, I'm not able to speak or understand or read the language, but boy, I'll tell you, the box art on those things really does make them enticing. So this sort of inspired me to see if after this trip, maybe I could do something to essentially solve this problem of making these games accessible. And the way that I went about this was using kind of the skill set that I do explore on a daily basis, which is employing artificial intelligence at the edge in Internet of Things type scenarios.
So these are the original cartridges here, and I see that when you go and you pick these up, these are the legit plastic cartridges. I saw you holding some up in the trailer. You can then take these, you can run them on the original hardware, you could take backups of them and run them on emulators. How would I make one of these accessible if I've got, Japanese text, it's in pixels, it's low resolution, it's going to be tricky to translate something like that. You can't exactly get a strings text file and start translating those.
No, so the trick that we sort of employ here is twofold. So number one, you hinted on something. How do we go from the physical cartridge to maybe something that we can actually interact with digitally? And the first thing is looking at a project called RetroArch, which I'm sure many folks who have ever explored this topic personally have encountered, which is for all purposes a front end and a spec for writing emulators in such a way, and emulators are ways to essentially run software on architectures that might be foreign to the original platform. For example, playing like your classic Nintendo or Sega types of games on a PC. And it does this in such a format that as long as an emulator is written to that spec, there's a common set of features and functionalities that can be exposed through this front end. And then that goes a step further in that there's a project called Laka.tv that actually takes this concept of utilizing the RetroArch front end that you see here and building a bare bones OS with which to run that front end from without incurring any sort of additional overhead for enhanced processing or anything like that.
It looks like on RetroArch and on this one, it says you can run these from the original discs. So you purchase this in Japan, you bring it back here. It might be a game from another region, but you have these physical discs and you're going to run them. The discs don't know that they're on a different computer, and that's okay. The instructions are then being emulated by one of these tools.
Correct. And so that's the way that gets us from the physical platform to a digital representation and an ability to really just play those, if you will, on a modern PC. And so taking that further, I looked at Laka as sort of the start here and started building a project called RetroArch AI with IoT Edge. And what this does, it leverages something called IoT Edge that we use for orchestrating containerized workloads down to IoT devices, and does this in concert with something called Cognitive Services Containers. And what that is our Cognitive Services offering allows for a number of different AI workloads that can actually be deployed as containers, just like the services you would know and hit with an API endpoint, perhaps running in the cloud. You can actually pull those services down and run them locally without necessarily having to incur any sort of outbound call to a web-hosted service. And so my target for looking at Laka was very interesting because I knew that if I could somehow get IoT Edge to run on that OS, then that would give me an ability to build essentially what we would call like a plug-out type of system that could allow me to interact with the features and functionalities of the RetroArch platform. Specifically, some things that it allows you to do is capture screenshots, being able to notice where those are, also being able to do things like split screens, so being able to have things go to one screen and another, which you'll see is going to be important in just a moment. And so the technical challenge here to get IoT Edge running was actually to go through and add support so that Docker could run on this bare bones OS. There were some things that were missing, for example, asynchronous I/O. And that got coupled with an additional project that I work on called the Azure IoT Edge Device Container. And what this lets me do is deploy a container that is the Azure IoT Edge runtime. So without having to actually install that on the host per se, I can actually deploy an instance, and we get into a bit of the Docker and Docker Inception world here, but then allows me to create an orchestrated ability to deploy things from Microsoft Azure down to a device, and that can, of course, include the IoT Edge runtime and Cognitive Services Containers.
Let me take a moment and see if we can level set, because there's a lot going on here, and I think that people may be thinking, oh, I know what he's going to show, and I know how it's going to work, but I think I understand what's different about this. So, you've got a game that you've purchased in Japan, you've brought it back here, you plug it into your emulator that allows you to get those pixels on the screen. Someone might be watching and saying, oh, he's just going to send screenshots into the cloud up far away and then translate them and then bring them back down. But that doesn't really make any sense because you're going to use a lot of bandwidth and you're going to have to basically stream the thing up into the cloud. But you have a powerful machine locally, right? You have a device that's on the edge of the cloud. It's not in the cloud. It's on the fluffy outer edge of the cloud. It's got power of its own. So you want to exploit that power. Is that correct?
Correct. So what we're going to effectively be able to do here is utilize the device itself as really a self-contained unit that can always be capable of performing these translations, okay, and not necessarily need to go to the cloud for all points of that operation. Okay. So,
and then the Laka Linux distribution and RetroArch and these different things are customized Linux distributions with with a lot going on. In my experience, a lot of them are held together with scripting and bailing wire and batch files and Python, and there are a ton of different things. They're very hybrid. Installing yet another thing on that could destabilize it, could confuse it. But by using containers, you're making effectively a compartmentalized little machine within a machine. And
Yes,
you're going to be able
absolutely.
to not call up to the cloud, but sideways to itself. Is that a fair statement?
Absolutely. And that gives me the ability to sort of be decoupled from any changes that might happen with Laco or RetroArch in general, because the service that I'm using is not necessarily baked into the code base that makes those things run. It's totally outside of it. So as you sort of hinted here, this is made up of some Azure services, the first of which is this concept of an IoT hub. And you'll see there's a few cognitive services that I'm using here in order to have access to an API key so that I can run those services locally in a deployment. And I'll quickly go through what that looks like. So inside of an IoT hub, you'll see there's a section here for IoT Edge, and that will allow me to see all of my devices that are effectively configured as edge devices and capable of receiving deployments. So in this process is going to require that the machine is connected to the internet at this point in time, because it has to receive that deployment. And so the device we'll be looking at today is a Surface Pro 4 that is running the system modules, the Edge Agent and the Edge Hub. These are system modules of IoT Edge that actually allow for the orchestration, the communication back and forth with the Azure IoT Hub, and something I call the Screenshot Translator, which is a custom module, and something called Cognitive Services Recognized Text, which we're using locally for the OCR component in this project. So what's interesting here is that with this Screenshot Translator module, we can actually set this up using something called a module twin to determine what language we ultimately want to translate from and to. The beauty of this is that Cognitive Services is smart enough to always figure out what the from language is. So as long as we go down here and set a property, which I've got set to EN, this is a prefix that comes from the culture prefixes for the .NET libraries that handle language translation. As long as that is set to something that it understands, it will always translate to that. Now, what I'm thinking to show for a demo here, and it's interesting, the latest version of these Cognitive Services containers supports the ability to detect languages like Chinese and Japanese. And when I first created this, it's funny, it was actually altruistic in that I could only translate things to any language but English, more or less, which was kind of debilitating for me because I wasn't able to play my games. But in this latest 3.2 preview container, it does support the ability to detect Japanese characters. And I was thinking we can go ahead and take that for a spin using the ever popular Zero Wing for the Sega Mega Drive. And if you don't know what this game is, you will certainly recognize it in just a moment here. So what I'm showing here on the left is my RetroArch screen. And what I'm going to go ahead and do is jump in here and launch up one of these games. So I'll launch up the European version of the game in question. And as soon as this loads up, all that I have to do is push this right joystick, and that's going to take a screenshot. And over here on the right, what I'm doing is utilizing something called IR Fan View that will allow me to monitor a hot folder and show these responses as they come through. So I did realize I just chosen English, and we're translating English to English. That's not super exciting.
Yeah, when you said European version, I was like, huh, we're translating English to English.
But what we want to do is go a step further, so that shouldn't be too surprising that worked. We'll go ahead and load the same game, but this time in Japanese.
One of your cartridges from overseas, from visiting the center of all video games in Japan.
Correct. And again, you might remember this one. This is the infamous All Your Base Are Belong to Us game. So you'll see, just as we saw before, as the text was mentioning AD 2101, we're getting that again. We can grab a screenshot again here and get some of this text that's going on here with the dialogue. Similarly, as we sort of continue here and get to the infamous part, you'll notice that it does successfully translate this as we're going on. So this is the part many of you have probably seen before. The enemy Katz, as he's named, who informs us that with the help of federal forces, all your bases. And you'll notice that there's a minor difference in that translation, and I wanted to point that out. We'll go ahead and stop our game here. Funny enough, there's a book about these translations, and this was the way that I sort of used to validate that this thing was in fact working. And on the, not only is cats mentioned here on the cover, but on the very back, it mentions to us that the proper translation of this in the Japanese version is that with the help of the Federal Army, CATS has taken over all your bases. And so you'll notice there is a bit of a variation of that in terms of what we've gotten in our result, but the majority of the context is retained here, and that's without going into all the nuances of the language. But what I've seen here is that by utilizing a service like this, you can begin to make sense of some of these games that would otherwise be inaccessible.
Were you pressing screenshots manually there, or would you have? How would you do it at a reasonable frame rate? And have you actually played some of these games at length?
So my decision when building this, and you can kind of see this in the screenshots that I'm showing here, was to make it on demand. And the reason why, while you could be creating these calls locally, on every frame, what normally happens when you're translating a video game is that something is shown to you, and you just need to really understand where that text is and what it translates to. So thinking like if you're playing like a role-playing game where it's turn-based, what's important to you is being able to look at a particular area of that screen and knowing, what does this say for me right now? And then you can sort of hopefully burn that into your memory and eventually start to actually learn the language of the game as you need it and be able to call it up on demand. So it is a manual process, but that was done deliberately in that the fast pace of certain games, you wouldn't be able to necessarily keep up with the gameplay if you were translating at the same time as playing it. You'd sort of fall behind. But this gives you sort of a reasonable way to really be able to look at, what am I seeing on the screen and how can I make that into something that I can understand?
Very cool.
And so if you're curious too how this all works, that code is up on GitHub. We do have, of course, the module that this works on is, of course, written in C#. And Scott, I'll just go ahead and challenge you real quick. Just given what you've seen on the screen, and I'm scrolling through some of this text, what do you think the process is for this working? And I bet you can figure it out. So it's a pretty simple algorithm.
I'm absorbing here. I mean, I am assuming what you've got a file watcher, you're doing screenshots, you're grabbing the frames. You could probably, if you wanted to be really clever, is do screenshots in memory and then just screenshot the diffs. So I had said you could go and screenshot every frame, and you're like, yeah, that's not really necessary. You could go and do it on demand. You could find a middle place and say, I've noticed text changing on the screen, and we've translated between, this bitmap hasn't changed, but the text below has changed. I noticed that you were also keeping the emulator on one side and the translation on the other. I wonder if you could overlay them, over the top of each other.
That is certainly a technique that, funny enough, at the time I was building this, RetroArch actually added support for exactly what you've described, utilizing a very similar technique. And you've more or less hit this on the head, Scott. We look at the image, we grab that when we know that we have a new image from the screen. We go ahead and operate on that to extract the text. Once we've extracted the text, we translate the text, and then we draw that back to the screen. And the trick for drawing it back is that when the text is extracted in the first place, we know the location using bounding boxes. And so we can simply fill in a black bar and rewrite the new text. Of course, there are some nuances to that where this may or may not work as intended, but for the most part, this simple algorithm allows you to take any frame and translate it. And if you think about that, it's not just video games that could benefit from this. You could think of live translating, I guess, any video feed, really using a similar process.
Interesting. And it seems like the most important part of that was that the cognitive services detection algorithm had that bounding box, and if it hadn't had that, that would have been a whole thing you would have had to figure out as well.
Absolutely. And so with that, I think that's a good point to really hit on, what's the big takeaway from what we've shown here today? Well, this is a use case that might seem trivial to some, or rather amazing to folks who might have a passion for games. The big takeaway here is that utilizing the container orchestration in IoT Edge in combination with these containerized cognitive services workloads gives us a nice ability to be able to bring AI down to the edge and perform these extensive types of operations like, where is the text and what does it actually say, and automatically inferring the language, utilizing these services. And if anyone is interested in checking these out, these are currently available in preview where you can pull down. It doesn't require a super powerful computer, although we are asking for at least a minimum on the latest release, 8 cores and 16 gigs of memory. And that's enough to, again, look at any text from, I want to say, 70 different languages, be able to pull that out, and also being able to use other additional services to translate that back to something that you can make sense of if you need to. So definitely would recommend checking out what's available here. And note that it's not just this computer vision workloads. There's tons of cognitive services offerings that are now offered as containerized workloads.
Fantastic. And I think this is really important for those folks who have made it this far into this episode, that while this is a really cool demo of some of Paul and my favorite things, the fundamental idea that the cloud is not just other people's computers in a warehouse somewhere that you can't see, bringing a piece of it, a chunk of that compute as close as you can, or in the example that you gave, side by side with some classic 30-year-old plus video games and the latest technologies around containers and the cloud and the edge is a new way of thinking about architecture.
Totally. I see these sidecar AI enhancements becoming a thing that will be enhancing not only legacy devices that we might have in our homes like video games, but think about legacy sensors out on factory floors and things like that. What you've just described there succinctly, I think, is going to be that dawning of the paradigm of AI at the edge workloads that we'll begin seeing in the years to come.
Fantastic. Well, thank you so much for sharing this with us. We're going to have links for everything in the show notes so people can go and learn about all these cognitive services, as well as look at the actual source code for the tool that you created.
Absolutely. And feel free to reach out to me anytime if you have questions about this. I'm on Twitter at PJDiCarlo. Would love to keep in touch, hear your ideas, hear things that you might want to do with these containers, or if you happen to rebuild this project, would love to hear what kind of games you're playing. So let's stay in touch.
All right. I am learning all about retro video game translation with C# and the Azure IoT Edge today on Azure Friday. Hey, thanks for watching this episode of Azure Friday. Now I need you to like it, comment on it, tell your friends, retweet it. Watch more Azure Friday.